Hello, this is an Astroneer tutorial on how to create a circuit that stores a binary number and allows you to add or subtract one from that number. So I've seen a lot of designs by some very smart people about adding two binary numbers together or subtracting binary numbers or doing various computational things between binary numbers, but I haven't seen something that stores a binary number and allows you to add or subtract to it. It's always two numbers together. It's never just, I want to, count up from 0 and keep going up and then count back down again. So I've created a circuit that does that. First, let's look at counting up in binary. Counting up in binary is ridiculously easy. We have each of these power switches standing in as a bit. Now they're all off, which means they're 0, and if I turn them on, they become a 1. What we have coming out of the power switch is a power sensor set to power lost, which triggers the next one. So just to count up, here's a 4-bit array. We start with 0. We have 1. Go to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then back to 0. So it is a very simple circuit to count up, but if you want to count down as well, it gets a lot more complicated. So this is the simplest design I have come up with to do both single addition and single subtraction. What we have is this entire line right here is a single bit. So we have the same basically 4 bits, but it's a lot more complicated to get both addition and subtraction. What we have here is this line is the actual bit indicating a 0 or a 1, but we have effectively what is a NOT gate, where we have this power sensor gained or lost coming out of this, and it triggers this power switch over here. So what this turns, instead of being that this is either on or off, indicating a 0 or 1, we have this off and this on indicating a 0, and this off and this on indicating a 1. This gives us the ability to generate an output when we have a 0, which is what we're going to need for the subtraction. So again, we have the same, it operates on the same principle where this is on power sensor, except this is on power sensor gain this time. What we have is we have a button repeater going into a delay repeater that triggers both this sensor and the power switch. So what this does is it effectively says, I'm going to add 1. So I'm going to flip this power switch to turn this to 1. But first, I'm going to check if there's power here. I'm going to turn this on and off very quickly. And if it is already a 1, because I'm going to flip this to 0, I want to flip this to 1 as well. And it repeats again where instead of a button repeater, we have the output of the power sensor, which is set to power gained, going into both the button repeater and this check. So the reason why we have the button repeater and the delay repeater going into this power switch is because we always want this power switch to be in the state that we expect. We don't want to be able to trigger this and have it just be on, because we want to trigger it on and off just to make sure we only have a single pulse to this power sensor to check if it is a 0 or 1. So this repeats down the line until you get to the end, and this is effectively, that side is effectively the same thing as this circuit, just a little more complicated because we want to be able to trigger the subtraction as well. So the subtraction works very similarly in that we have a button repeater going into a delay repeater, which triggers this power switch, which is the check for the power sensor, again, we're checking power gained. But because there is power when this is 0, we know when to pass along the signal. Because if this was a 1 and we subtract 1, we're just changing this to a 0. In that case, we don't have to propagate anything down the path. We just have to change this from a 1 to a 0. But if this is a 0, we have to check the next step over here and keep going. And if this is a 0, we have to check the next one and the next one. So it's the same setup where a button repeater goes into both the power switch and a delay repeater, and then the delay repeater goes into the power switch. And it's slightly different from this side. So both this delay repeater and this delay repeater are triggering this power switch. And the reason we have that is because this power switch is controlling the NOT gate. So if we trigger this power switch, then the NOT gate will handle that and flip this switch. Whereas if we flip this switch, we do not have a NOT gate on this side to change this. So let's look at this in action. Right now, it's all 0, as you can see, 0, 0, 0, 0. We're going to add, get a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's everything. And then you go back, goes back to 0. And we can do the subtraction as well. So we're at 0. This is just going to go to 15. And we can go 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So that is an addition subtraction circuit that allows you to add or subtract 1 from a binary number. If you like this video, please subscribe, and thanks for watching.